Now in this video we are going to discuss some important points or important theorem related with the rational number and their decimal expansion. You already have learned this in the lower classes, but now in this you are going to learn as a theorems. You know this very well. Now the first theorem is, let x be the rational number whose decimal expansion, means x is any rational number whose decimal expansion terminates, मतलब जिसका decimal expansion terminate होता है, मतलब खत्म होता है, then x can be expressed in the form of p by q. Whenever the number, any number x which is the rational number whose decimal expansion terminates, then that x can be expressed in the form of p by q, where p, q are co-primes. Okay, and this is important, the prime factorization of q, means denominator, is of the form 2 raised to power n and 5 raised to power m, में whose m, where m n are non-negative integers. means simple language में अगर किसी decimal terminating decimal है, this is terminating decimal expansion, is it? So now if like this, then it can be expressed in the form of p by q, where q is in the form of 2 raised to power n or 5 raised to power m. How it is? Now you can write this. You know this how to write. 45 divided by 100. Why 100? 2 decimal points, 2 digits are there. Okay. Now you can 45 into, now 10 can be expressed as 5 into 2, isn't it? Sorry, 100, and it's square. Why? Because 10 square. I can express 100 as a 10 square. Now 10 can be written as 5 into 2. These are the laws of indices you have learned in the standard. Okay, now it is 45. This is 5 square into 2 square. Now what you observe, this is the q, is it? This is the q in the form of p by q, which is expressed as power of 5 and power of 2. That is the meaning of this theorem. Means whenever there is a decimal expansion which terminates, that can be written that p by q form, and where its denominator have either 5 or 2's power or both's power. Now it is not in the reduced form, because here what is given, that the co-prime, so you can reduce it. Now you can reduce it like 9 into 5, you know that 45, and it is 5 square into 2 square. Now 1 square get cancelled with 5, it is 9, 5 into 2 square. Means the denominator q is expressed in the powers of 5, here 5 raised to power 1, that is you can take as m and n. Why? That m and n are different and that are non-negative. That are non-negative. Here power is 1, here power is 2. They never be negative. This is the meaning of this theorem. But you have to just go through this theorem, read it twice, thrice, so that whenever there is a fill in the blanks or statement writing, you can write it. Okay? I hope you understand. Another example you can take. Suppose this is 1.25. It is terminating decimal expansion. Now I can write it 3 digit. We can take the 3 digit suppose. Okay. These are the 3 digit 1, 2, 3. So I can write 250. How many decimal points? Move forward, that many zeros. This you learned already. The 1, 2, 3. As 1, 2, 3, 1, 2, 3. Now this 1 get cancelled. Sorry, 0 get cancelled. Now it is 25. Now it is again what? 10 square. Okay, 10 square. 125. 10 square means 5 square into 2 square. Okay, laws of indices. 10 can be written as 5 into 2. Now 125. Okay, 125 can be written as 5 cube, as you know that this is the 5 square into 2 square. Now I am here only theorem up till now that p by q is of the form 2 raised to power n and 5 raised to power m is over. But we have to prove this also that P and Q are co-prime. Here PQ are not co-prime. Here P and this is Q not co-prime. They have something common. Now this 5, this cube and as cube and get square get cancelled. Only 5 is remains. That is 5 upon 2 square. Means what you observe that whenever there is a terminating decimal expansion, then that P by that can be written in the form of P by Q, where PQ are co-prime. As here you can expand this for 5 by 4. These are the co-prime and can be, and their denominator have either power of 2 or power of 5, or in this example what we observe, power of 5 and 2 both. Okay, and where m and n are non-negative integer. Okay, now let's see another theorem. Theorem number 1.6. Let x be P by Q be the rational number. Now x is given in the form of P by Q already. Okay, number such that the prime factorization of Q is of the form 2 raised to power n and 5 raised to power m. अब हमें क्या दिया हुआ है कि x is P by Q फॉर्म में है और Q is of the form 2 raised to power n or 5 raised to power m. This is given to you. Then you can directly say that P by Q will terminate. This is the meaning of this theorem. Okay, means अगर आपका P by Q फॉर्म का कोई नंबर है और if you have to observe its denominator and you found that the denominator is of the form either 2 raised to power n or 5 raised to power m or both, then that P by Q definitely terminate, because you know that rational numbers are categorized in the two, either terminating or non-terminating and repeating. Okay, so you can by observation and by use of this theorem only you can say that the given P by Q means rational number is terminating or non-terminating with recurring, so that these theorems are useful. MCQs are asked generally depends upon this two theorems only. So you should know that if your Q is of the form 2 raised to power n or 5 raised to power m or both, then that P by Q definitely terminating rational number. So let us take example. Let us see some example. Now x is given as 5 by 4. Now what you can observe, this is the rational number. These are the co-primes also. Now 4 is of the power 5. I can write 4 as a 2 square, isn't it? Now what you can say by using this theorem, this will definitely terminate. You can do the division and you can observe this also. 5 divided by 4. 4 ones are 4. Okay, then it will be 1 carry. If you are taking 0, then it will be 2s are 8, then 2 again 0, it will be. Now what you observe that if the denominator having the power of 2's only, then also your decimal expansion of this rational number is terminating. Is it? Now by division we have to carry out division and then we are going to say that this is the P by Q, that 5 by 4 is a terminating rational number, rather than you can use only the theorem, as here power of 2 is there only in the denominator, means this decimal expansion of this rational number will terminate. We can take the another example, that is now 7 by 8. Now 7 as it is, I know what is the 8? 8 is 2 cube. Again here is power of 2 only. If you carry out the division, what you will observe? 8 zeros are, then 7, then 64. What you will get here? 6. Okay, 0. 6. You will get 4, and if you divide 5, definitely this is going to be terminating. But doing this, we are doing this in the lower classes. Now directly by this theorem you can say that as the denominator 8 can be written in the form of 2 raised to power something, so this will definitely terminating. Okay, now this is about only 2 is there. We will see two another examples. Now here this is the p by q here. P by q is of the form 3. I can write 25 as a 5 square. Means here denominator q is of the form only 5 raised to power something. Let us see, is it the terminating or not? You have done this, I think, in the 7th standard. 25 अगर ऐसा रहा, so how to convert into decimal? Either by division I taught you. Now in this direct by, now 25. To make the 25 as a tens power, we can write it as a 4. I multiplied it. This is the another method to convert equivalent fractions actually. Okay, and to convert them into the decimal. You have learned this method. See, this is the another method. Now 3. As you multiplied by the 4, here also you have to multiply by the 4. Now but you can observe that it is the 12 upon 100. And this can be written as 0.12. Is it? Now means this this rational number p by q form, when in the decimal expansion it is terminating. So while rather doing this all things or previous division method, you can just observe its denominator. Denominator have the form 5 raised to power something, then that will definitely terminates. Okay, now let us see if the denominator, क्योंकि यहाँ बोला गया है कि 2 raised to power और 5 raised to power अगर रहा, दोनों भी रहा तो 2 रहा तो भी होता है, 3 रहा तो 5 रहा तो भी होता है. Now let us see this one. Now 350. Okay, now it can be written as 3 into 50 na. Now it is 50. I can make into 100 as a multiply by 2. It is the way, and this is the method one of the. So I have multiply by 2. Now it is what? 6 upon 100. Is it? 6 upon 100. And it can be written as 0.06. Again it is terminating whenever both the powers are there. Now I can explain this again. 100 can be written as 10 square, that is 2 into 5, 10 square 6, that is 6 upon 2 raised to power 2 into 5 raised to power 2. Means whenever there is a 2 power as well as 5's power, that time also this rational number is going to be terminating decimal expansion. Here also there two are there, and by division also you can prove it. Now this is how we can directly say that if the p by q is terminating or not. If denominator have the powers of either 2 or alone 5 or both together, that time that p by q definitely the terminating decimal expansion. And the first theorem is, if the decimal expansion of any rational number is terminating, that means that p by q, when you write it in the p by q form, there q has the form of 2 raised to power n or 5 raised to power m, where m and n are non-negative. Means that can be 0. Non-negative का मतलब होता है 0 और positive. Okay. Now let us see the last theorem of this chapter. Now let us see the last theorem, that is only the converse of this. Okay. Means if the p by q is the rational number and q is not of the form 2 raised to power n or 5 raised to power m, that time that rational number will be non-terminating and repeating decimal expansion. मतलब अगर p by q में से q का फॉर्म जो q है वो फॉर्म 2 raised to power n या 5 raised to power m नहीं होता है, that time that decimal expansion will not terminating, is non-terminating and repeating. You have seen like these examples, isn't it? This is called the non-terminating and repeating or recurring word is there. These are the type of rational number you have did in the last year, 9th standard. Okay. Now, suppose what we have to say that 3. As 3 is not of the power of 2 or 5 or both. 3 is not in the form of 2 raised to power n and 5 raised to power. You cannot write. If you carry forward this division, 1 divided by 3, what you will get? 0, then 10. Now point 3, 9, again 3, sorry, again 1, again you have to give 3, again 9, and so on. This is what? If the q, this is the q, is not of the form either 2 raised to power m or 5 raised to power m or both, that time that p by q rational number is always non-terminating and repeating decimal expansion. Now this is how we have completed here our chapter. Thank you.